YouTube stream. Okay. So there we go. Let's talk about, let's get after it. I know you've got quite a few good questions here, so hopefully these will be not too difficult to figure out. So here we go. The first page, we've got, what was this from? Like a review sheet?
Yeah.
Or was this like an old quiz or something? It says work is required for credit. Is that how the teacher talks about just regular homework?
Yeah.
Okay. This first one is kind of a tricky one. What I'm going to do is, we've talked about U substitution, right? Are you comfortable with when I say let U equal log base 3 of x? Are you comfortable with that?
Yeah.
Okay, because this is going to be a quadratic. First of all, I'm going to take this 2 and bring it down to the front, because remember, I can do that. And when I do that, I can see that I have really just u squared plus 2u plus 1 equals 0. Do you see?
Yeah.
Okay, stop me if I'm losing you. Which means u plus 1 squared equals 0. Which means we have no solution, I believe, because that would mean that u equals -1, which means the log base 3 of x equals -1. Oh no, actually we do have a solution, which means 3 to the -1 equals x, or x equals 1/3. Got it?
Yeah.
And we can check that answer, as we are accustomed to doing. Oops, what happened to my calculator? Sorry, I thought it was going to be up already. Give me a sec. Give me a sec. Wait, is this my calculator? Oh, maybe that is my calculator. Yeah, that is my calculator. Sorry, I forgot what it looked like. I was just in the graphing version of it. Okay, so let's remember how we talked about checking. Have we talked about this? If I type in 1/3, which is my answer, and I store that for x, hit enter, and then if I type in carefully what it is that this says, which is going to be, let's see, I'm gonna think it's in math mode, log base 3 of x, and I'm going to square that. See how I'm being very careful how I'm typing them in? Plus, I might as well write this the way that it was originally, which is log base 3 of x squared plus 1. And when I hit enter, what answer should I get?
I wonder. Oh, wait. Sorry. You should get 0.
I should get 0 because I'm plugging in 1/3 basically into
Yeah.
that, which is what I get. So I know I did it right. Okay. Questions about that?
No.
Okay. So this next problem, notice what I have again. I've got an exponent. And what did I say I can do when I have a exponent inside the argument of a logarithmic function? What can I do with an exponent? Bring it out front, right? So this would equal log base 10 of x times log base 10 of x, right?
Yeah.
Equals 4. See how I did that?
Yeah.
Okay. And then this is really just log base 10 of x squared, quantity squared, equals 4. And what can I do to both sides of this? How do I get rid of a squared?
Oh, you take the square root of both sides.
Take the square root of both sides. So I have log base 10, which I don't really even have to write I don't have to write base 10 because if I don't write a base, the assumption is that it's base 10. Log of x equals positive 2 or the log of x equals negative 2. This means that 10 squared equals x. And this means 10 to the negative 2 equals x. This is x equals 100. And this is x equals 1 over 100. So those are your two answers for that problem. And if you plug it in, we can just manually plug it in. In fact, up here, if I plug 10 squared in here, that's going to be 10 squared would be there and 10 squared would be here. They'd be in both places. Log base 10 of 10 squared is 2. So this is just 100 squared. Or I'm sorry, that's 10 to the 4th. Yeah, so that would be 10 to the 4th. That whole thing would be 10 to the 4th. And log base 10 of 10 to the 4th is just 4. So that did work. You follow how I'm doing that? 1 over 100. If I plugged in 1 over 100 or 10 to the negative 2 in both places, 10 to the negative, log base 10 of 10 to the negative 2 is just negative 2. So you have 10 to the negative 2 raised to the negative 2. So you multiply the two negative 2's, which gives you 10 to the 4th, and there we go. Log base 10 of 10 to the 4th is just 4. So that checks out as well. Okay, did I do that too fast, or you follow that okay?
I think I get it, yeah.
Okay. Again, stop me if you have questions. I've changed to blue so you can see it better, or you know what I'm doing. All right, this problem looks so what I'm doing right now is I'm actually thinking like a chess player. I'm trying to think several steps ahead to figure out what the best approach is to do this problem. Now for you can't see what's going on in my brain. That's why I'm talking through this stuff, and that's why I don't mind if I have to start over. I'm just going to kind of think through this a little bit to try to figure out what the best way is maybe to solve this problem. So well, I could, if I wanted to, I could bring this x squared up to the top here, and I could bring this x up to the top here, and then I could combine these. How do these things combine? Do you remember? Do you remember how you combine, what subtraction is related to?
It's just related to division.
Right, so if I had log base b of x over y, I could rewrite that as what?
You could rewrite it as rewrite it as log base of x minus log base b of y.
That's right. And so I could also go the other direction. I could go this direction, right? I could take a subtraction of log as long as the base was the same, which it is, and I could turn it into a division. You understand what I'm saying?
Yeah.
And I think that's probably the best approach here. So I'm going to try that first, and let's see what happens. So first of all, I'm going to take these and bring them up to the top like this. I know it seems complicated, or it seems like I'm making it more complicated, but I think I have a good feeling this is going to work out. So this is log base 10 of 8 to the x squared over 5 to the x. Got it?
Yeah.
And this is, well, I know that that's 2 over log base 2 of 10. Okay, hold on. I've got another idea. 10 see what I'm doing is I'm thinking about this. 10 is 2 times 5, right?
Yeah.
So couldn't I rewrite this as log base 2 of 2 plus log base 2 of 5? You understand that?
Yeah.
Log base 2 of 10 is equal to that, isn't it?
Yeah.
I can't distribute that 2 inside there because it's being raised to a negative first power. Boy, this is a tricky one. I'm having a hard time seeing the best path for this, because if I did this, I don't know that that would necessarily help me, because I'm still going to have a negative exponent on the outside, and then I'm going to have 2 terms. I'm going to have a 1 here and then a log. I see what's going to happen. I have a feeling what's going to happen. This is going to be 2 to some power here. This is going to be like 2 to the 3x squared. And that's 5 to the x. And see how that, so that's a 2 and a 5, and I have a 2 and a 5 here. I think that's going to somehow relate to these things. But I don't know exactly how, because I still have this x over here that I'm just going to try to deal with and figure out what that has to do with anything. Better idea. Let me try this. So one other thing I can do is I can rewrite this log base 2 of 10. Remember the change of base formula? If I have the log base b of x, that is equal to, I can pick a different log and I can change the base to that. So I'm going to change it to base a by putting the x on the top and putting the b on the bottom. Remember that?
Yeah.
So I'm going to actually do that. I'm going to write 2 times. This is going to be the log base 10 of 10 over the log base 10 of 2. And this is to the negative 1 minus x. Okay, now the reason I would want to do that is because what's the log base 10 of 10? What's this equal to?
Equal to,
The log base 10 of 10 is just 1,
yeah. Yeah.
right? And
Yeah.
what do you remember one of the properties, if you had like a over b to a negative power, do you remember that you can flip the b and the a on the inside and make the power positive? That's a property of exponents.
Yeah.
So I'm actually just going to flip this. So this whole thing just equals 1. So that's 1 over log base 2. Well, that really just is 2 times the log of 2 minus x. You see where that came from?
Yeah.
Or was that too magical?
Oh, I see where it came from.
Okay, now I'm kind of reconsidering maybe what I did on the other side. By combining those, I kind of feel like maybe that wasn't the best thing to do. Again, it's like a chess match, right? I'm thinking ahead, I'm looking forward, and I'm seeing, I like how my right side has become more simple, right? Do you see that? It's a very simple thing. In fact, I can bring this 2 up to here and make it just log base 10 of 4. And on the left side, I have all log base 10s. I still have an x I'm trying to deal with. So I'm kind of thinking about bringing the x's. Trying to think of how I can simplify log base 10 of 5. I feel like there's a simple There's a simplification for log base 10 of 5 that I'm just not seeing. This is a doozy of a problem right here. I feel like I'm not seeing something. 8 is 2 cubed, right? Erase this. Let me try a different thing. 8 is just 2 cubed. So I could bring that 3 down front. So there's a log base 10 of 2 times x. Log base 10 of 5. Oh, actually that's x squared. So this would be, let me rewrite this. This is 3x squared log base 10 of 2 minus x log base 10 of 5. And see how 2 times 5 is 10? I feel like that's going to somehow be related to what I'm doing here, but I'm just not exactly sure how. So let me subtract. Okay, let me teach you another trick. Sometimes when you can't find a solution to something, it's good to go away and work on some other problems and come back to it. Sometimes a fresh approach will help you, because I'm not seeing where that's going quite yet. So let's come back to that later, okay? We'll hang on to number 16. Let's look at number 17. Man, you got some tricky problems here today. What kind of a assignment was this again?
This was just our homework for today.
This was your homework. Wow. That's some challenging homework.
It was supposed to be challenging, yeah.
Yeah, I mean, this is challenging stuff. Very challenging stuff. So let's see. For this one, I'm going to try to break these things apart. So there's log base 5 of x. And this next one, I'm going to color code these for you. This next one is going to be log, put parentheses around this. This is going to be log base x of 5 plus log base x of x, which is just going to turn into 1. And this last one is going to be, I'm trying to think if there's I actually don't even know the property. Were you given any other properties about, like, if you have a base that's a multiple of 2 things, what you can do with it? Like, do you have a property I've not seen, a log base AB, where there's a product, your base is a product of something? If there's a way to break that up. I mean, I suppose I could okay, I've got a couple ideas for this. Okay, let me start over. Here's my next idea. I'm going to change all of these to base 5x. No, I'm going to change them all to base x, maybe. Let's try that. If I change everything to base x, now I'm using the change of base formula over here. So this would be log base x of x over log base x of 5. Got it?
Yeah.
This is still just log base x of 5x. This one is going to be log base x of y over log base x of 5x. And this is just equal to 4. I don't even have to do much with that one. So this is 1. Do you see how these cancel each other out right here?
Yeah.
That and that cancel each other out. Got it?
Yeah.
So this is log base x of y, that's on the top, over log base x of 5, that's on the bottom, equals 4. Now I can go the reverse direction from the change of base, and I can turn this into what? Can you see? Can you tell me what this is going to turn into?
That would turn into
I'm basically going in the opposite direction with the change of base. I'm getting rid of the base x. So that would be log base 5 of y equals 4. Do you understand?
yeah.
Which means 5 to the 4 equals y. So that's your answer, whatever 25 squared is. Okay, so having done that, it gives me a little motivation for the one above it. Do you see how when I decided? So again, let me talk through the method, because do you understand how I did that problem, number 17?
Yeah, I see how you did that.
But you're probably thinking to yourself, well, how am I going to think of that? Like, how am I going to think to do that? Well, that's kind of the point of these sorts of challenge problems. The point is you try something, kind of like putting a puzzle together. Sometimes you just try a couple pieces and they don't fit, so you take them apart and you try, you go look for other pieces. You know what I'm saying? That's kind of one of the things about these sort of challenging math problems. So I'm going to just start over. I'm going to try to start fresh on this one and see if now, having done that with success, that last number 17, if that will help me do this problem. Maybe I can see something a little bit different about this problem that I wasn't seeing before. Like maybe a change of base type thing. Or maybe a substitution type thing. So I still think I like the idea of making this 3x squared log base 10 of 2 minus x log base 10. I wish this was log base 10 of 2. That would just be a lot easier if it was. Because I know that this one over to the right, like we simplified before, is 1 over log base. So this is just log base 10 of 4. Is that what we had said before? Minus x. Well, we know log base 10 of 2 is just a number, right? That's really all it is. Log base 10 of 2 is just a number. It's not a rational number, but it's just a number. 10 to what power equals 2. So it's just a decimal. So really what I have here, if I move everything over, is I have a quadratic. I've got 3 log base 10 of 2 times x squared minus, I'm moving everything over, so that means I'm adding x and I'm subtracting log. Do I clean that up there? I just moved everything over, save some space. Did you get it? I didn't throw you off there too much? I just moved, I moved the 2 terms on the right over to the left. so that I set it all equal to 0, because now I'm going to take these x terms here and I'm going to factor an x out. In fact, I'm going to factor a positive x out. And if I do that here, I would have a negative log base 10 of 2, which just is log of 2, plus 1. So that's really just my coefficient. I factored an x out. I'm going to put the x on the right side of it so it looks more like a quadratic. So there's my linear term. And then it's just minus log base 10 of 4, which again is just a number, equals 0. I feel like I can simplify this a little bit so it's not so ugly. Let's do that up here to the right, upper right corner by the date. 1 minus log base 10 of 2 is kind of like saying log base 10 of 10 minus log base 10 of 2, which is the same as saying log base 10 of 5. Didn't I have a log base 10 of 5 before? Hold on, that's my log base 10 of 5. Did I just go in a big circle? Did I write that wrong originally? Should this have been 5 right here this whole time? It should have been, shouldn't it?
Yeah.
Did I have that written wrong? Okay, so this shouldn't be 10. This should be 5. Which actually, maybe that's going to make this even better. Because if this is 1 minus log base 10 of 5, then it's log base 10 of 10 minus, because this is 1, right? Which is just log base 10 of 2, because I'm dividing them. So this is really just log base 10 of 2. Okay, I'm starting to like this a little bit more. So I've got 3 log base 10 of 2 times x squared plus log base 10 of 2 times x minus, I'm just going to write 2 log base 10 of 2 because we've got all the other ones in terms of 2. Log base 10 of 2. Whoops, log base 10 of 2. So I have a quadratic, which means I can factor. Right?
Yeah.
Wow. What if I let u equal log base 10 of 2? Would that make things a little bit easier to see how that factors? Does it factor, or do I have to use the quadratic? I'm guessing it's going to factor. I definitely need some more space. So let me duplicate this. Do you want me to keep going with this? Or do you want me to move on? Because are you lost, or are you following what I'm doing?
Kind of following what you're doing, but at the same time, it's a little bit confusing for me.
It is confusing. It's a confusing problem, and there might be a simpler way to do it. But like I said, I'm showing you the process of a mathematician, what you do as a mathematician. So let's let u equal log base 10. I don't even really have to say log base 10. I can just say log of 2. Because if I don't put a base, the assumption is it's a base 2, 10, base 10. Okay. So what I have here is 3ux squared plus ux minus 2u equals 0. So I'm hoping this is going to factor. I'm hoping it factors into 3ux and x. And then like, I'm going to guess and check here. Minus 2u and plus 1. Do you see what I did? Because now this is negative 2ux and this is positive 3ux. And what's positive 3ux minus 2ux? 1ux. I've factored it. Follow that okay?
Yeah.
And now I can see where this is going to go. So what I have is 3ux minus 2u equals 0, 0 product property, or x plus 1 equals 0. So either x equals negative 1, and I'm looking back at the original, and that is okay, because x is not inside. That doesn't make, logger, that doesn't cause me a problem to make it negative, like sometimes it does. Or I have, now I'm going to resubstitute log base 2. Or I have, actually, no, I'm not. I'm just going to solve it for x. Or I have x equals 2u over 3u. Oh, wow. And look what's going to happen. The u's are going to cancel, which is just 2/3. So my answers are either 2/3 or 1, negative 1. So that worked. Should we check our answers?
Sure.
I'm a little nervous. Are you?
Mhm.
Let's check 2/3, because that one, chances are, would not be the right answer. Sometimes negative 1 and 1 and 0 work mysteriously, even though you did something wrong, you got the right answer. But 2/3 probably, if it works, I would be pretty confident that we did it right. So I'm going to type in x squared times log base 10, which is just log of 8, okay, minus x times log of 5, okay, and I'm going to hit enter. So that number should be the same as what I get when I plug in the other side of the equation, which is 2 log base 2 of 10. So I'm going to have to go to my math, get my log base 2 of 10. And I have to put a parentheses. You have to be really careful. See that? I have to put a parentheses on the outside, and then I have to raise that to the negative first power. Got it? Minus x. Okay. Cross your fingers. Are you crossing your fingers? What should I get for this? You see what I did? I plugged it in over here, plugged it in here, and I plugged in here, and these should be equal to each other.
Should get the same thing, yeah.
So I should get negative 0.064.
And negative 0.6, yeah. Oh, hey, that's.
And I did. Got it?
Oh, yeah.
Now,
Can I just see the work really quickly again once
yep.
more?
Yep. Let me just show you a quick way I can check the other one in case you wanted to. Negative 1, store x, enter. Now just hit second enter, and it's going to toggle through that. Second enter again. That's the, now it's plugging negative 1 in there. It's second enter, second enter, second enter. It's toggling back through, and I should get that same decimal, which I do. So both of those were correct answers. So again, let me walk you through the thought process. So what I did after, see again, you see how I went away and I did a different problem, and it kind of gave me some ideas. Well, I came back here and I couldn't help but think, you know what? Look at this. I've got a log base 10 of 2. I've got a log base 10 of 5. And here I've got a log base 2 of 10, or this is a log base 10 of 4. I'm just thinking to myself, there's got to be a way to simplify this. And kind of the key here was what I did right here. When I moved everything over, I recognized that I have a quadratic here because I have an x squared and x terms and then a constant term, right? See these? Here's an x squared term, here's 2x terms, and here's a constant term. So I'm thinking to myself, well, I'm going to combine them together. But as I'm combining them together, I'm recognizing things. I'm like, oh, look, I can factor an x out of these two terms right here. And that's going to give me this, but this can be rewritten as a single logarithm. That's what I did up here. See how I did my work up here, thinking, okay, this is like log base 10 of 10. Oh, okay, this, I can combine these together by dividing 10 and 2. Oh, wow, that's just log base 10 of 2. I'm like, oh, wait a minute. I have a log base 10 of 2 here. Now I have a log base 10 of 2 here. And I can rewrite this instead of log base 10 of 4. I rewrote it as a log base 10 of 2. Why would I want to do that? Because now I can take that factor, basically what I'm doing, honestly, you could have just divided that out of everything. I'm an idiot. You know what would have been a lot easier? Again, a lot of times you see the easier thing when you go back. What if I just divided the entire thing by log base 10 of 2? That's gone, that's gone, that's gone. You see what I'm saying? I actually could, I didn't even need to have that u there. This whole time, that u, I could have just canceled it out. I could have divided everything by the u. I didn't even need to do that. And again, sometimes you see the easier solution when you're done with it and going back through, okay? Do you follow how I did that?
Yeah, I'm kind of just looking through it again.
Yeah, that's going to be a tricky one. You're going to want to watch that video again, or even just kind of think through it again. So this u, even though it canceled there, I could have canceled that out long before. I just didn't. It didn't dawn on me that I could have done that.
All right, yeah.
All right, let's try to speed through some of these other ones. Solve for x and y. Is this a system of equations here? Is that what that is?
It looks like it.
I'm guessing that that's what that is intended to be. Wow. Well, so again, my gut feeling is let's write them all in base 10. Let's just see what happens. So this would be log of x over log of 9 plus log of 8 over log of y equals 2. And this one below would be log of 9 over log of x plus log of y over log of 8 equals 8/3. Now, do you know that one trick that you can just flip? You have can I do that? Can I just flip all of them?
Sorry, flip all of them meaning what?
I'm trying to think if I can take this. What I would like to do is just take the reciprocal of both sides, but I don't think I can do that because this is a sum here.
Yeah, I'm not really sure. Maybe you can combine them. Yeah, that's what I was thinking.
Combine them together and then flip both sides.
Yep.
I think that might. Yeah.
Well, that would
Log
be a
8
long,
log.
that would be a long calculation. So I'm not really
It
sure
sure
if it's
would.
worth it. But I think it might work because that works for rational functions.
Right, exactly. Again, this is kind of the process that your teacher wants you to go through, is to think through, well, how could I do this problem? So this would be log 8 over log 8. And this would be log. No, that's ugly. That's gonna be too ugly if I do that. I don't like that idea. Also, sometimes if you just write a problem out underneath to see 1/3 plus 1/4 equals 1 equals let's see, what would that be? 7/12. I can't just flip it. 3 plus 4 does not equal 12 over 7. Definitely can't do that. So yeah, I can't flip that. So what can I do to try to combine those? I could try to solve one equation for one and use. Oh yeah, that's what I can do. I can solve one of the equations, then flip it. That's what I'll do. So here's what I'm going to do. I'm going to take this equation, the top one, for example, and I'm going to solve it for the log of y. So log 8. Oh, actually, you know what? I don't even think I had to do all that. If I'm going to, yeah, I do have to do that. Okay. Again, there might be an easier way to do this, but I'm just going to do what comes natural to me, which is this. I'm solving for that. So I'm going to type, I'm going to write, I'm going to subtract log x over log 9. Okay. And now I'm going to flip it so I can substitute it in. But I'm going to be careful when I do that. So this is going to be log 9 over log 9. So 2 log 9 minus log x over log 9, which means log y over log 8 equals, now I'm going to flip it, log 9 over 2 log 9 minus log x. Oof, if I like that. But see, now I can substitute this into here. And is it going to be a complicated thing to solve now for log of x? Okay, well, let's see if we can simplify this now a little bit more. Because that equals log of 81 minus log of x, which is equal to log of 81 over x. So I could write it like that.
Oh.
So let's try it. Let's plug it into there. So what we have when I plug it in is I have log 9 over log x plus, I'm substituting this whole thing in, which is log 9 over log 81 over x, which equals 8/3. Is that helpful? Not really. No, I don't like where that got us either. So scrap that. I don't like that plan. But I'm not going to erase it. I'm just going to duplicate it, okay? That's the other thing is when you're doing this stuff, I'm going to have to delete some of these at the end though, because it won't let me duplicate anymore. Whoops. There's a limit to the number of Jamboard slides you can have. So I'm deleting those. And I am duplicating this one. Okay, so let's try it again. Let's try a different thing. Do you have an idea? Do you have some suggestions? Anything cross your mind as we started doing this stuff? Maybe change of base wasn't the best idea. Isn't there a way you can flip them? I think if it's related to change of base. How is log base y of 8? Can I rewrite that? Oh, I think I can. Hold on, I just thought of something. If I did the change of base, but then I raised it to the -1. I can't just arbitrarily raise it to a -1. Oh, I know what I can do. I can write 1 over log y over log 8. I could do that. Which is 1 over log base 8 of y. Okay. There, I just came up with a theorem, I believe, a property. So if I wanted to rewrite this, I could rewrite this as 1 over log base 8 of y. Would that help me? And I could do the same with like with this. I could rewrite that as 1 over log base 9 of x. You follow what I'm doing here?
Yeah, I see what you're doing.
And that might allow me to get, because what I'm trying to do, my goal here is to get this. I want to be able to add, I want to be able to essentially eliminate or substitute in for something. And I think I can now. So let me try this. Let me see if this helps, if this happens. So I'm going to rewrite this in terms of log base 8 of y equals log base 8 of y equals 8/3 minus log base x of 9. Okay. And now I'm going to plug in no, I don't like that as much as what I was doing on the top. Let me solve for log base 9 of x. Now it equals 2 minus 1 over log base 8 of y. No, that's not what I wanted to do. No, that's not what I wanted because I want to substitute for that other thing. Sorry. Let me do it like this. 1 over log base 8 of y equals 2 minus log base 9 of x. And now I can flip both of those sides. So log base 8 of y equals 1 over 2 minus log base 9 of x. We'll see if that's going to be doable. So now I'm going to substitute this into here. So I've got log base x of 9 plus 1 over 2 minus log base 9 of x equals 8/3. What I'm doing, I think, is getting toward the right answer, but I don't think that's the best way to do it either. But you see kind of what I'm having to mess with here and work with? Do you understand what I'm doing?
Yeah, I don't see what's happening.
I see what I'm doing, but again, I feel like those puzzle pieces may not have been the best fit, and I might now try something slightly different to
Yeah,
get to
these
that
are
solution.
pretty complicated.
Right. It's a complicated thing, but I feel like it's getting close. I still don't know if that was quite the right way to do it though. So let me try this. Let me try to rewrite. I'll change color so I don't get it confused with different colors. So let me try like this. Trying to determine if I want the X. I don't think I want I don't think I want the variable to be part of the base. I think that would make it more complicated. So I'm going to rewrite all of these things so that the variable is no longer part of the base of the logarithm. So this first equation would be this. Okay. The second equation would be 1 over the log base 9 of x plus the log base 8 of y equals 8/3. So I'm going to take a second here to see if there's anything else that, now that I have things written in a way that seems a little bit more like these are the same and these are the same, and I don't have variables in my bases anymore. So it'll be easier to solve it at the very least when I do combine them together, however I choose to do that. So I'm going to write this equation down here as I'm going to solve it for this and then plug that in. Oh, I'm going to do it and see what happens. So log base 8 of y equals 8/3 minus 1 over log base 9 of x. Now I'm going to plug that in to here. So I have log base 9 of x plus 1 over, color coding, 8/3 minus 1 over log base 9 of x equals 2. Maybe I should have cleaned that up first. Let's get common denominator to see if this works. This is going to be 8 log base 9 of x minus 3 all over 3 log base 9 of x. All right. So if I had written that in there, would that have been better? Oh, kind of. because this whole thing going into here means that I can now just flip it. You understand? And I would really just have log base 9 of x plus 3 log base 9 of x over 8 log base 9 of x minus 3 equals 1.
I think that it would be better to just leave this problem because my math teacher said we did not have to do all of them. He said that if some of them were looking like they might not come to a final solution, it would be better just to kind of leave the work as it is and come in with a question.
Yeah, that's probably a good idea. This is tricky. I think we might be getting close to the answer here, possibly, but now again, I'm trying to decide if should I use U substitution? Should I get common denominators? Because really what I'm trying to
I
do
think it
here
would
is
be
this.
better just to ask him what he thinks the best like way to really
Yeah, that's
finish this
good.
problem would be. Because
Yeah.
yeah.
All right,
Because
that
in
sounds
case it
good.
shows up on the exam, like I doubt that it would show up, but if it does
I
show up,
doubt it,
then
yeah.
yeah.
All right, so number 19 surprisingly looks a little bit better.
Yeah.
In my mind, because I think this might just be one of those change of base things and everything kind of falls out.
Yeah, my teacher did mention that a lot of these would have a change of base, so I wouldn't be surprised if that's the case here.
Yeah, so
Let's,
if we do it,
yeah.
let's just see if we get lucky. So that's log x over log 3. And this is log 2x over log x. So those are going to cancel. And this is log y over log 2x. So some of those are going to cancel. And this is just equals well, we'll see what we have to do with that. We might want to bring the 2 in front. We might want to leave it there. But let's see what cancels first of all. This cancels with that.
Yeah. It would just
That
be log
cancels with
y
that.
over log 3 equals log xy squared.
Right. So log y over log 3 is the same as log base 3 of y equals log base x of y squared.
Yeah.
I'm trying to solve for y, x and y.
I guess if we were to put, I'm not really sure if we should bring the 2 to the front or not. 2 log x of y equals log 3 of y.
So yeah, let's go back to change of base. What are you thinking? Change of base again? See if that's going to help us. Log equals 2 times log y over log x.
Should be good.
So yeah, so if we what we can do is divide both sides by log y. Right? You follow what I'm doing?
Yeah.
If I divide both sides by log y, well, first of all, that means that if log y equals 0, that's one of our solutions. So we have to consider that, which means y would equal what? Y equals 1. That's one of our solutions. Because the log of 1 is 0. Oh, no. It can't be. 10 to the, oh yeah, no, that's right. Y equals 1. 10 to the 0 equals 1. You follow what I did there?
Yeah.
So before we just cancel out the y's, or the log y's, we have to consider, hey, wait, before I cancel those out, couldn't the solution be if the log of y equals 0, then those two sides of the equation would equal each other? That and that would equal each other because they would both be 0. So that's why I had to take that. That's why before I just canceled out a factor, it's kind of like when you cancel a factor of x out of both sides. Well, that just meant that x equaled 0 was one of your solutions. So log y equals 0 is one of my solutions. But now I can find the other solution by just solving this. 1 over log 3 equals 2 over log x. Cross multiply. Log x equals 2 log 3, which means log x equals log 3 squared, which means x equals 9. So there are my two solutions. X equals 9 and y equals 1. Do you see how I got that? I know I kind of jumped around at the end there. Maybe that yellow part that I did was confusing to you as well. But I just recognize the fact that the log of y, if it's kind of like if I had this problem, x squared plus x equals 0. What's the solution to that? So what some people might say is, oh, I'm just going to divide both sides by x. Like divide everything by x, which means x plus 1 equals 0. And that's true. X equals -1 is one of your solutions. But your other solution really was the fact that you should have thought of factoring out an x. Right? And then that means that x equals 0 is a solution as well. So if you're going to divide both sides by something, you just have to make sure that you set that whatever you divided both sides by, whatever variable expression you divided both sides by, set that equal to 0 and solve for that, because that's one of your solutions. Got it?
Yeah.
Does that make sense?
Yeah.
All right. I know we're over time, but I'm kind of having fun. This problem looks kind of familiar to me. I feel like I've done this before. Do you have an idea about how to do this?
No, I do not have an idea of how to do this. I think we might have done some of these in a past session. I think in the last session, I copied and pasted this. This worksheet was kind of reassigned to us. Like, yeah.
Okay. Yeah, these look kind of familiar to me.
Yeah,
Not entirely.
I think we did the rest of them. Those are just the newer ones, I think. The ones that we've already done.
Okay, so that's it. We're good.
Yeah, we're good.
Okay. Well, that was intense. That was an
Yeah.
intense session. Some very challenging problems, to say the least. But I think again, the process that we're talking about is really what math is all about, right? It's not just being able to solve problems, it's being able to go through the process of problem solving and learn from those processes. So that's really, even though I couldn't, snap my fingers and get those problems right away, that doesn't mean it was, that's not a bad thing. The process is really the goal here.